Okay, solving each inequality, graph the solution set and write the answer in interval notation. Graphing is minor, interval notation is major. All right. I'm expecting everybody to be able to put it on a number line. But again, the more advanced you get, we really just don't use number lines anymore. All right. So I'm probably going to get away from that. But using the number line also helps you with interval notation in case you're having some issue. All right. So let's see what you can do for question number 1. All right. Now, again, I still like to keep the variables positive. All right. So here we go. I have what? 4x, and then that would be 16. And so now 4 less than or equal to x. So that means x is greater than or equal to 4. Do I have any issues? Yes.
Why did you switch to
Okay, remember, we talked about this. 3 is greater than 1. So if I compare 1 to 3, we say 1 is less than 3.
Yeah, but how do you know if the x is bigger?
Because it says x is greater than or equal to 4.
But why would you switch it from the rest? Because
So what you did on yours is you forgot when you divide by a negative to switch the sign.
oh,
All right? Makes sense now, right?
yeah.
All right. All right. So if you choose to keep if you choose to move the 7, you'll have a negative 4x is less than or equal to negative 16. Then when you divide by negative, you change the sign. All right. Again, very important. Make yourself some notes where you make your mistakes. All right. Now, if you're greater than or equal to 4, if I had to do that on a number line, it would be very easy. You would say negative 4, 4, solid dot at 4, going to the right. Or you would say what? As interval notation, bracket 4 to infinity. That's what I'm looking for. Anybody have any questions or concerns? All right, let's check out number 3. All right, we'll do the evens with my other class. All right. So here we go. Now we're just doing a little distributive. So here we have 7x greater than or equal to negative 12 plus 6x. Does that make sense? All right. Now we do what? Yep, so I moved the 6 to the left, correct? And so that would just leave me with what?
X is 13x.
Greater than or equal to negative 12. Be careful, Connor, it's not 13, right? Yes, because for those guys who forgot, right, just make sure you're doing a good job reviewing. Technically, you would be what? Subtracting 6x, subtracting 6x. Connor, you see that? Right? And the next mistake is what? People forget to distribute the negative properly. So that negative times that negative makes that a positive. All right, please be careful with that. Any questions? You good? All right. So let's do the interval notation, guys. Let's just do interval notation. All right, so greater than or equal to negative 12 would be a bracket at negative 12 heading off to infinity. There you have it. Number line's not necessary. All right, let's check out 5 with me. All right. Connor, you with me? All right, I want you writing these down. You're not copying the answers. You're trying to do the problems before I do them. All right. So here we go. Just to make sure, minus 2x. Well, let's just do minus 2x. I'm all right with that. And minus 29. and you have negative 5x less than or equal to negative 20. Is everybody happy with that? Now remember, when you divide, you have to do what?
Change the sign.
Change the sign. So here we go. Divide by negative 5. Divide by negative 5. So x is greater than or equal to what?
4.
4. All right. Go ahead. Come on.
What if you
Okay, I'll show you that real quick. All right. You should have, it should be exactly the same, honestly.
it is with the
Exactly. So let's just do it again. Right? So I'll show you just in a comparison. All right. So if we were doing it that way, where you add 3x and you subtract 9, you end up with 20 is less than or equal to 5x. So x. So if you reverse it around, see what I mean? Same answer, right? All right. Now again, some of you guys now, it's important you're speaking up. Speak up, speak up. Connor, is that good with you? Michael? It's going to be hard. It's on some of you guys real bad if we don't do a good job on Thursday.
Did you do 4?
Because why? You can't?
No, yeah, well, I had a question on. Okay, so I distributed, and then, so when you distribute, it's 2x minus 12x plus 32.
What is it?
Yeah, and then, wait, so you add 2x and 12x? Okay, sorry. Yours is a good
So who was right?
value.
Is that what you got? Good. All right, there you have it. So this would be from 22/5 to infinity. Agreed? All right. Number 7. Something like that, right? Combining terms. Now, if I subtract 4x and add 3, it looks a little awkward, but 0 is greater than or equal to 2x, right? So 0 everybody okay with that? Less than or equal to 0, right? Come on now, this was a hard one, okay? This is a really, really good review problem. Really good review problem. So please speak up. Go.
What you did from the first step you wrote down under that?
Good for you, buddy. Look, watch this. Look how easy. See this right here? And this right here. That's that right there. Everything else stayed the same. Do you agree? Because negative 12 plus 9 is negative 3. Simple. Look how easy that is. Right? Just let me correct you. Go.
So, oh, actually, no.
You got it? Figured out. Good. Connor? Still good? You got number 7 right? James? 100 on your test. All right, I'm not kidding. Number 9. All right, I put a little note to the side. Yeah, try that. It's okay. It'll hurt the first couple times. Okay? What'd you get? Well, you haven't thought yet is what you're trying to say, right? Haven't thought yet.
Okay.
For number 9, what do I do?
Okay. Let's go back up to it. So you want to subtract on both sides.
Right.
So you get 3x is less than or equal to 3x minus 16.
Good.
And this is weird, but
Hold on a second. Hold on. Let me write what you wrote down. So first thing, she subtracted 9. So 3x is less than or equal to 3x minus 16.
this is a little weird. I subtracted 3 from both sides.
Subtracted 3x from both sides.
Yeah.
Perfect.
And I got x is less than or equal to negative 16.
Wait a minute, though. Look, this is your mistake. If you subtract 3x, what's 3x minus 3x?
0.
0. Not just x. It's 0x, which is 0. So 0 is less than or equal to negative 16, which is a, right, but that's a false statement.
Yeah, because it's not possible.
Not possible. That's right.
Because
So this is false. Therefore, it is no solution. Therefore, it is no solution. Now, again, I'm asking you to think on that now. All right, you got to think a little bit. Or it's not the traditional problem. What?
Okay, so for 7, it's 0, but since it's 4,
Yes. Yes, but listen, the difference, well, it has nothing to do with the arrow as much as it has to do with the fact that it's not 0x. That doesn't cancel out. That's 1x. Right? The other one can be 0. You can be greater than 0 or less than 0. Right? You have to have a variable involved. When you get to this question down here, it's false because what happens to the variable itself? It cancels out. Do you agree with that? All right? Now what I want to do is I want to think about number 10. Bella, right? What did you think about number 10?
Is it 0x is greater
Yep.
than negative 9?
0, but we wouldn't necessarily say 0x. I think it's easier if you just say 0 is greater than negative 9. Is that true?
Oh wait, yes. So it's 0.
This is definitely a true statement,
So then it's
which means it's always true. Listen to what I just said. It's like saying, when is x plus 1 greater than x? Always. It's always bigger. So you would say, because that's a true statement, we would write it like this. All right? In the past, you remember we wrote it like this. All reals. All right? So lots of options. That is a true statement. And you can't understand that if you're not thinking.
So you write it like this.
Yes, that's okay. And then interval notation, though, would be negative infinity to infinity. That means every number. Yes.
If the greater than was it greater than equal to? Where do
Yes,
you
it's still a true statement.
put,
Zero.
but where do you put the bracket?
There are no brackets. It's always true. It's like saying, when is 0 greater than or equal to negative 1? Always.
But
There's no bracket because it's any number, which means you can go infinity or negative infinity. All right, now I'm going to let you think about 11 and 12 on your own.
What about the negative 9?
That's what I was trying to tell her. Listen, this is just because there is no variable or the variable cancels, it's either a true statement or a what? False.
Oh,
If it's true, it's negative infinity to infinity. If it's false, it's no solution. All right? So here we go. So now we're on to compound inequalities. So for the first couple, I'm trying to get you to visualize things. All right? So if I'm less than negative 2 or greater than 5, right? Sometimes it might be easier to write out the number line, but I'm trying to get away from that. Negative 2, this direction, 5, this direction. Everybody see that? That would be the answer. All right? However, we're going with interval notation, which means Don't forget negative infinity is over here, infinity is over here. So we'd say negative infinity to negative 2, union 5 to what? Infinity. Come on. It's not equal to. Equal to is a bracket. All right. Now, let's just go ahead and jump on 14 just to make sure you understand. That literally means x is what? In between negative 3 and 7, right? Negative 3. Now we have a
Negative 7 bracket.
or positive 7.
Wait, oh, sorry.
Negative 3, comma, bracket 7. Good?
Yeah.
Connor, new topic now. Just reviewing with you. You good on that? All right. Here we go. Now we got to do 15 together. All right. So here we go. 3x is less than negative 36, right? So x is less than negative 12, or 2x is greater than, or x is. Now, again, I'm trying to get you to visualize the numbers better. So if you are less than negative 12 or greater than 14, you would be from there you have it. Yes, ma'am. Good job, Sandra. What?
So for 14 and 15, for 14.
I'm not asking about 14. Oh, yes, I did. I'm so sorry. Go. 14.
You just put the 2 in the brackets, but why did you make them separate for 15?
Well, because it's between. This means right here, x is between. X is between. On the other one, they're going in what? Opposite directions.
If we, on the test, we don't put the U, will you count it?
Well, it's not a matter of counting it wrong. Just don't forget it. It's technically not wrong, actually. All right? It's just the, and by the way, listen, guys, and this is a technicality, and like I said, when you get to higher advanced math, they do symbols and stuff. Union, listen to me, this is kind of silly. It's not union. I just say this symbol looks like a what? U. Does everybody see what I'm saying? It's not, just listen to me. It's not really a U. It's the symbol, right? So again, there's a lot of symbolism that I'm introducing a little bit, all right, that will help you later, all right? If you just write this down, a lot of math teachers just say write that, all right? But the symbol means, it means both answers combined. That's what that means. Both answers combined. That's what union means. All right? So let's go ahead and do, I'm going to go ahead and do, bless you, 16. 16. Here we go. So the only thing I need to do on 16 is what? Divide by 2. So I have negative 2 less than or equal to x less than or equal to 4. Somebody with me on this? Right? And so again, we would just say bracket negative 2, 4, bracket. Guys, that's not that hard now. All right? What makes it difficult is if you don't know what you're doing. All right? Does anybody have any doubts, any questions? All right. So listen to me. It's not that it goes away. Listen to what I'm trying to tell you. That is a great answer. This is the answer in like a simplified format, right? Because I try to tell people, mathematicians want to shrink things down and do them as quickly as they possibly can. Simplify notation. Do you hear me? So those are both the answer. Do you hear me? So it's not that the x went away. It's just a different way of writing it. Do you hear me? All right. So let's check out 17. All right. What do I need to do? First, help me.
Add 4.
Add 4. Don't be shy. So I'm going to add 4, so it'd be negative 4x is greater than, and then x is, be careful,
It's the other way.
other
X
way.
is less than 2.
It's the other way. Thank you for that mathematical term, the other way. Now we would have what? 5x is greater than,
45.
so x is,
Greater than 9.
right. So if you're less than 2, that means you're going from, and then you're going from,
9 to
perfect. Perfect, perfect.
Oh. Oh yeah, sorry. I just have to.
All right. Now, listen, for question 18, we have to do what to both sides? First, you have to do add 7 to both sides. And then divide both sides by 3. All right? Nothing to it, guys. I think that's kind of intuitive also. You should know that. You add 7, add 7, add 7. Negative 12 is less than or equal to 3x, which is less than or equal to what? 15. Now we're going to divide by 3. Negative 4 is less than x, less than or equal to 5. Does everybody hear me on that? All right. And so, bracket, negative 4. Beautiful. Okay, so now we're at a thinking question again. All right, all I'm asking you to do is to think first, say it, and then think it through, and then tell me the answer. Drew,
Everything in between negative 2 and 2.
read it to me.
What do you mean by that?
I want you to read the statement. X is what?
Oh, x is less than negative 2.
So now in your brain, you're thinking of all the numbers that are less than negative 2.
Oh, okay, and then x
Is
is greater than 2.
so all the numbers greater than 2. What numbers are less than negative 2 and greater than 2?
None.
That's why it's no
Yeah.
solution.
Okay.
All right, that's the whole objective there on that now. All right, those are the hard problems because it just requires some extra thought. All right, you can't be less than negative 2 and greater than 2. All right, and those are the questions that sometimes they put on standardized tests. All right, which separates kids. All right, so here we go.
So you add
Now, is it possible to be less than negative 7 or greater than or equal to 6? Yes.
Yes,
Yes.
Because-
it's an or statement.
Because it is an or statement. That's what I'm trying to get you to understand. All right, that's what I'm trying to get you to understand. Okay? So I think what I did here was I just changed the numbers up and created more problems for you. All right? So that's just extra practice. Okay, let's look at the thinking question for number 26. Jump down to 26 because this was the hard one. This is the really hard. All right, so look at 26. If you are less than 2 or greater than negative 2, what do you think this is?
I'm seriously in the conversation.
Yes. What do you think?
It'd be negative infinity to 2.
um,
Because
What
if
do you
you're,
think? That's okay.
if
That's
you're
all
less
right.
than 2.
Be careful. What do you think?
oh. Oh wait, I have to make it better.
What are you thinking?
Would it be negative 2 comma 2?
What do you think? What do you think?
Negative 2 comma 2.
What do you think?
Negative
Yeah, I
infinity.
think-
It's because it's 0, it cancels out.
So here, this one is the hard one. So I'm going to try to tell you something here, and I want you to try to listen to my explanation, please. Give me a number. Think of a number that's less than 2, and think of a number greater than negative 2.
Negative 3.
Hold on a minute. Shh. So all I want you to do is I want to try for you to give me a number that's not less than 2 or not greater than negative 2. Give me a number. Just listen to my explanation. I promise you, as soon as you realize what I'm saying, you'll see it's obvious. Give me a number that's not less than 2 or greater than -2.
3.
Oh, okay.
All right, so let's try 3. Is 3 less than 2? No. Is 3 greater than -2?
Yes.
So 3 is out.
Oh,
1.
1. Is 1 less than 2?
Yes.
So that's a solution.
So then why would it be negative?
I'm asking you, give me a number that doesn't work.
There's a lot
That
of
doesn't
numbers.
What
15.
what doesn't work?
15.
Remember now, an or statement means it only has to be true for one of them.
How about -17?
-17, is that less than 2?
Yeah.
Then that works.
I don't think it-
All right, so let's look again at the number line. If here is 2 and here is -2, if I'm less than 2, hear me out. If I'm less than 2, it could be anything over here.
Oh my
If
God.
I am greater than -2, I go in this direction. If it only has to be true for one of them, no matter what number I pick, it's going to be true for what? One of them.
But this number has to be true for both.
Yes, that's perfectly fine. An or statement can be true for one or the other or what? Both. That's the difference between an and. And has to be true for both. Or has to be true for just what? One of them. All right? So again, go back and listen to what I said for number 26. That's really as hard as it possibly gets. All right? So here we go. Reviewing absolute value inequalities. We write it the way it is. 3x minus 6 is greater than 12. And then we write it as 3x minus 6 is less than -12. Now I had people every single year who do absolute value inequalities. They only do it for one number. And that means every single one of their problems is wrong. Absolute value inequalities is when there are two solutions. All right, you have to remember that. Make that note. All right, so now when we solve this out, 3x is greater than, so x is greater than 6. Over here, 3x is less than, so x is less than. So if you're greater than 6, or you are less than -2, right? So greater than is always your or statement. Less than is always your and statement. All right, but it's not necessary to memorize that if you understand the notation. Everybody happy with that? Okay, so here we go. Let's do, that was a greater than, let's go ahead and do a less than, number 28. So we do 4x minus 20 is less than 8. 4x minus 20 is greater than -8. Everybody see that? All right. So 4x is less than 28. X is less than 7. 4x is greater than 12. X is greater than 3. If you're less than 7 and greater than 3, hold up for just a second. You would be from 3 to 7. Now again, listen, your job, listen, is tomorrow I'm going to do as much as I possibly can. Scroll through this. There is a lot of problems. For those of you guys who want a great grade, do more, not less. All right, we're spending time tomorrow. Study.
Yes.
Are a bowl of cereal.
I'm supposed to be Roman noodles instead of
Oh, ramen noodles. Very funny. I got it now.
Hi.